This is the second problem from the Lord of the Rings Incline Plane worksheet. It tells us that Legolas is sliding down the stairs on a shield in order to attack the Uruk-hai. The stairs make an angle of 38 degrees to the ground. The coefficient of kinetic friction between the metal shield and the stone stairs is 0.18, and the coefficient of static friction is 0.24. With what acceleration is Legolas attacking the Uruk-hai? Legolas, with all his equipment, has a mass of 86 kilograms. And it gives us a picture and then a simplified diagram. So the simplified diagram, this is our inclined plane, and here's Legolas sliding down. If we list what we know, given, it tells us that the angle relative to the ground, so the angle of incline, call that. Okay, so we want to draw a force diagram for Legolas. Here's our surface. We've got FG going straight down, FN going up. He's got a frictional force parallel to the incline. And then if we break apart FG, we have FGY and FGX. We're looking for acceleration, so we need to use the force diagram to figure out what his net is. From the force diagram, right minus left, and this is to the right of the incline, we know that F net is going to equal FGX minus FF. We also know that frictional force is equal to mu Fn, and from our force diagram, normal force equals Fgy, which means that frictional force equals mu Fgy. Substituting frictional force equals mu Fgy in for Ff, we get F net equals Fgx minus mu Fgy. Now let's break everything apart. F net is equal to mass times acceleration. This equals Fgx, so Fg is equal to mg. The x component of Fg would be times the cosine of theta, minus mu. Fg again is mg. Y component of Fg is times the sine of theta. All of my masses are going to cancel because it appears in all three terms. So acceleration equals g cosine theta minus mu g sine theta. I can factor out a g on the right hand side, so a equals g cosine theta minus mu sine theta. Now all I have to do is put in the numbers. So a equals 9.8 newtons per kilogram times the cosine of 52 degrees minus the mu we want to use here is for kinetic friction because he is sliding, he's not standing still. So that we're going to use the 0.18. The static friction coefficient was just a distractor, it's an extra piece of information, times the sine of 52 degrees. When we put all of this into our calculator, you're going to end up with 4.64, keeps on going, meters per second squared. And with 2 sig figs, acceleration is approximately 4.6 meters per second squared. This problem and number 1 on this worksheet, so the one right before it, mass is irrelevant. So solving number 1, if you didn't already, you're going to follow the same steps where you want to break everything apart. And when I say break everything apart, break apart net force, break apart Fgx and Fgy into these right here. And you'll find that masses will cancel. They're irrelevant. Also, what you want to make sure you do is recognize what frictional force is equal to and what normal force is equal to. In the next practice problem, so the worksheet that says practice problems, numbers 2, 3, 4, and 5 are all similar to these 2 inclined plane ones. where you'll be able to break things apart. Masses will probably cancel, I think, in all of these. So 2, 3, 4, and 5 are very similar to these two problems.